Okay, so now I want to differentiate each of these using the chain rule. So more examples here. Okay, so let's differentiate each of these then. So sine, so we'll get that times derivative of that. So sine will differentiate to cosine, won't it? So it'll be 8 cosine 8x for number 1. Number 2, so differentiate again, so it'll be 2x times minus sine x. So we get minus 2x sine of x squared. Okay. For number 3, we've got e in there. Now make sure you know how to differentiate e before you get any further here. So this will differentiate to 6x times e to that. Reason why is because e doesn't change. You need to know that e does not change when using the chain rule, and in general anyway. For number 4, sorry, we've got e to the root x. Now that's y equals e x to the half. So I have to differentiate x to the half, which is 1/2 x to the minus a half. Yeah, times e to the root x. Okay. For number 5, we've got e to the power cosine of 3x. Well, remember, if you got y equals e to the kx, then its derivative is k e to the kx. Yeah, that's what I'm using here. So we've got cosine 3x will differentiate to minus 3 sine of 3x. Then I need to multiply that by e to the cosine 3x. And I can't really tidy that up. I'll have to leave that as it is, unfortunately. For number 6, we've got y equals sine of tan of x. Now don't forget, sine is differentiated to cos, and tan differentiates to sec squared. So that's another derivative I would write down. Even though it's in the formula book, I would honestly suggest writing that down because it's quite helpful actually, I find. So, derivative of what's inside, which is sec squared, will come outside. That will multiply by sine of that. So which is whatever sine differentiates to, which is cosine of tan of x. So you got sec squared x cos tan x. And the last one, we get 2x minus 7 multiplied by cosine of x squared minus 7x plus 8. And that is how we can differentiate each of these functions using the chain rule.